Good afternoon and welcome to this webinar provided by SMTA Europe. Today's presentation will be given by Keith Bryant. My name is Bob Willis and I'll be helping to organising today's session. Before we start talking about our subject of today, which is a pre-conference webinar covering some of the aspects of our Electronics in Harsh Environments conference, I'd first like to introduce you to the control panel. Now, the control panel allows you to do a number of things during the presentation. First of all, you can open and close the panel by clicking on the orange button. This prevents it obscuring your view of the slides during the presentation. You can click on the blue button. This makes the image on your screen or in your projection facility in your conference room go full screen, thus giving you the best view of the slides during the presentation. Now, if you have any questions during the webinar, you can type them directly into the control panel as indicated here by the red arrow. Now, Keith will be answering questions at the end of the presentation this afternoon. So if you have a question on a particular slide, a particular point, then please just type them in anytime during the presentation and those questions will be answered at the end of the session. Please remember this is an introductory webinar on the conference and some of the topics just to give you a flavour of the presentations that are going to be coming in the not too distant future. It's now my pleasure to introduce our speaker of today, Keith Bryant, and he is chairman of SMTA Europe. And Keith's on the line, and I'm just going to say hi, Keith, and get you to swap over screens. Good afternoon, Keith.
Good afternoon, Bob.
You have the power. You are in control.
Thank you kindly. Good afternoon, everybody, and welcome to Electronics in Harsh Environments Conference Taster. As Bob has said, we're not going to be doing all the presentations this afternoon, obviously. We're just going to give you a taster of the sort of things that are going to be there. We have a confirmed program already, which I will go through later. Okay, sorry about that, guys. Here's the website for anybody who hasn't logged on. A little bit of background. Smart Group UK officially became part of the SMTA in January 2018. We're very excited to be part of a huge international organization, which obviously brings a lot of benefits. And having a technical team in Europe organizing these kind of events hopefully is going to bring value to SMTA members in Europe and also bring value to those people who aren't members but will be interested in coming along to our events. This event is actually the second. We had a very successful event in Amsterdam last year, and we had, as you can see from the images, we had a good level of people at the conference, and we were very well supported with tabletops. This was, if you like, this was the initial event. This year, we've decided to focus on the hot topic of electronics in harsh environments. Like Bob, I travel around the world at a lot of, let's call them, pertinent events. And this topic has been one of the hottest that's been around for at least the last 3 or 4 months. So we believe it's the ideal thing to be putting out to all the people who are coming to visit. I'm going to start by running through the program and the venue and a few other things, and then I'm going to look in a bit of detail at some of what I consider to be the key people who are speaking. Some of them are keynotes, some of them are part of the standard program, and I will then hand over to Bob, who's going to talk about 1 or 2 others that he has more knowledge of than I do. As you can see, Electronics Harsh Environment Conference, 24th to 26th of April, the Clown Plaza, Amsterdam, Schiphol. Schiphol is the main international airport in Amsterdam. It's very easy and cost-effective to get to from most airports around the world. Schiphol is obviously a hub for one or two airlines, but it's a major center for most. We got very good comments from people who traveled last year who said it was very easy to get there, and it was not that expensive to fly either. Obviously, the earlier you book your flights, the cheaper everything is going to be. Day one is Tuesday. Registration is open from 8:30 in the morning, and we have what you could call professional development courses, or us old-style people would say that they were workshops. Bob is going to talk about Martin Wickham's, which is the first one, a little bit later. The National Physical Laboratory in the UK is one of the leading research centers for electronics-related projects, and the increasing the performance of organic PCBs at higher temperatures is a presentation based on a whole load of work which has been done and was completed quite recently. Martin and Bob were very, very closely involved in it, so you actually have basically very good information coming from the horse's mouth. The afternoon development course, Understanding Shock and Vibration, from a gentleman from DFR Software. This is designed for reliability. This is probably the leading, if not one of the leading US companies in this field. And I've seen their presentations from around the world, and I have to say, it will be interesting and exciting for everybody. So if you can manage to come on the Tuesday, which essentially is the day before the full course starts, it will be a very interesting time. The course starts, or the event starts, on Wednesday morning. Again, I'm not going to go through all of the presentations. You can read them there yourself. The one that I'll focus on and talk a little bit more about later is the research which has been done at Cree in the US. Again, anybody who doesn't know Cree, they are one of the leading manufacturers for high spec and high reliability LEDs. I saw this paper a couple of months ago, and I have to say there's data and information in here which anybody who does anything related to LEDs is really, really going to benefit from. The other papers, University of Rostock, NPL again, University of Hanover. So very, very strong papers from what I would describe as some of the best industry experts from Europe and the US. After lunch, we break into two streams. We have effectively 4 sessions in the afternoon. Reliability of solder alloys and electrochemical reliability running in one room. And then we have the session 3 and session 4 running in another room. And again, we have Mike Bixelman speaking. Mike is one of the leading technologists in terms of contamination and cleaning and conformal coating. He speaks at events all around the world. I was recently at an event where he won the best paper. And you know, I have to say, he's a joy to listen to. Dr. David Bernard, I have known personally for many years. He's definitely one of the foremost authorities in X-ray technology, and any presentation by him is definitely worth listening to. Session 4 in the afternoon, we have one of, we would consider to be the highlights of the event, Doug Pauls from Rockwell Collins. Anybody who's been to any of our major events before have probably seen Doug and Dave. They are tremendous speakers. Doug Pauls was indicted into the IPC Hall of Fame last year. Dave Hillman was indicted into it last week at the Apex exhibition in San Diego. They both have decades of really strong work in process development, in failure analysis, and also they do a lot of work with standards committees at the IPC and also the J standards. Doug is going to talk about putting together data and information for the new J standard 001. And Dave has a really interesting paper. I'm going to share a few slides from this later on the issues that you can get with conformal coating process and the effects that it can have on joint integrity. Everybody says conformal coating is a great thing. It's a great mitigation for tin whiskers. It has a whole load of advantages. Dave is one of these people who pretty much tells it like it is. And as he said, not everything in every garden is rosy. So again, really, really interesting papers. We also have papers from Mike Conrad from Aqueous. Again, I have a few slides on that later. Brilliant presenter coming over from the US. One of the best presenters that you would see. Really, you know, I have to say, when I'm going through this and talking about it, I'm even more impressed by the quality of speakers that we have coming out to what is effectively our second event in Europe. People that I've missed and not talked about. Graham Wilson from Indium, also very, very strong speaker, presents very, very good data in a simple and concise and easy to understand way. So yes, that takes us through to the end of day one, but really, really good, strong presentations. I think, to be honest, the only problem that you have with day one is deciding whether you will go to session 2 or session 3 or session 4 or session 5. Obviously, in the break, you can switch between the two. And even if you want, probably as long as they're running to time, you can even switch from room to room between presentations. But there's a lot going on. It's very hard to choose from. Obviously, anybody who comes to the event will get all of the presentations after the event anyway as PDFs. So if you miss something or there's two things going on at the same time, you're well able to catch up later anyway. Thursday, we have a welcome message from Grace from INEMI. Again, anybody that doesn't know INEMI, they produce some wonderful data and forecasting on technology, what is going to be changing in technology, new technologies that are going to have an effect on our industry going forwards. So anybody who has half an eye on the future, it is well worth coming and listening to that. Again, we have Eric Kotz, who's coming over from Binghamton University. Craig Hillman, again, who's coming over from the US. So we have, again, really strong people. The increasing high reliability of plastic ICs is a paper that I've also read already. And I have to say it has some really interesting and relevant data and will probably change the way that you think about high temperature reliability with what would traditionally be lower temperature quality products. Session 7, we're talking about high temperature PCB materials and fabrication. Again, we have some of the leading people to talk about the fabrication and the materials. Kirsten Lux from Robert Bosch. Again, I'm going to talk a little more about his paper later. Really, really interesting. Also, the Indium and the AIM guys have done a lot of work on categorizing lead-free solder alloys and also new alloys to run at high temperature environments, predominantly for the automotive industry. So the automotive let's say the automotive trend or thread, which is running through Thursday, again, Thursday morning produces some excellent work, which is well worth listening to. We finish with something which is a little bit new for us. I have to say, I'm looking forward to it. We're working together with INEMI, and we have an interactive forum. We start with a panel discussion, and then we have 5 breakout groups, and you're welcome to join any one of the 5. And those groups are going to look at all the different technologies, from robustness validation for mission profiles through to the utopian target of 0 defects, and looking at sustainability and the current and forthcoming environmental regulations. And then each one of the groups is going to have a few minutes to report to, let's say, the whole audience. And then the conference concludes at 5 p.m. So huge amount of stuff going on. A lot of things to decide which you think is more important to spend your time, but definitely one of the strongest programs in harsh environment for with electronics that you're going to see, definitely within Europe this year, and probably further afield as well, because it is a really international panel of speakers, and every one of them is a person who's well worth listening to, who has stuff that they can say. In addition, we already have a good level of tabletop exhibitors. And again, these guys are also worth talking to. It's a nice, relaxed environment at the conference. At the tea breaks and the lunches, you're able to spend time and chat with these guys to learn more about their technologies, and more about what they bring to the party of high reliability electronics in harsh environments. The number of tabletop exhibitors will grow, obviously, but these are the guys that we have signed up today. As I said, I want to just give you a sample of a couple of papers, and then I'm going to give you also a sample of a couple of the abstracts. For me, this is going to be one of the strongest presentations. Dave Hillman, as I've said, great presenter, humorous, explains things in a very simple, concise way, and has a wealth of material, and also behind that, a huge wealth of knowledge. Just go onto the internet and Google David Hillman, Rockwell Collins, and you'll find a huge quantity of papers and presentations and everything. He did a great one a few years ago, basically about, is this the end of the void of the voiding issues for BGAs? Really worth a look. A huge amount of very interesting and relevant information. And as I say, there are 37 people in the IPC Hall of Fame since they started it decades ago. Dave Hillman has now been added, and Doug was added last year. So basically, these guys are the best of the best. Dave is going to talk about the investigations that they've done, the test vehicle that they did it on, the thermal cycling that they ran on the assembled products, and very much in detail what those results are. Also some modeling that they did, and the conclusions that they draw from this work. So again, very simple, very straightforward, very concise, and the conclusions are really going to be of interest. Excuse me. As Dave says, there's a huge advantage to conformal coating, but if you look at the pictures below, you can see occasionally with acrylic, there are some quite nasty things going on underneath that BGA. And if you look at the cross-section on the right, I can only describe that as very scary. I'm not going to tell you any more, because basically the aim of today is to give you guys a taster of what you'll see when you come to the conference. So we're not going to give you all the conclusions. We're not going to give you all the data, because purely and simply, first of all, it would take too long. And secondly, then there'd be no reason for you to come to the conference. And this is all about giving you or your management or whoever you need to convince reasons for you or someone in your organization to attend the upcoming Amsterdam conference. Again, very interesting information from, again, David draws a lot of information from work that other people have done already. This is a case style of an unusual failure mode, and David is rolling this into his presentation because effectively it's all based on acrylic conformal coating and the issues that you can get from this, and also other conformal coatings as well. As I've mentioned already, Michel Conrad from Aqueous is a very, very strong presenter. He puts together some of what I would believe are the best quality presentations that there are around. A gentleman who's well worth coming to listen to. You might think because he's working for he's the owner of Aqueous, that it's a very commercial presentation, but exactly the opposite. Mike is a very technical guy, and he presents very technical information very, very well. And as I've said, has great images. This image of dendritic growth, which is on the left-hand side, is for me, showing this to your boss and saying, look, this is the sort of stuff that we're going to talk about, and this is the sort of stuff that could start happening to our products, is probably good enough reason to come to the event on its own. But Mike is taking a slightly different than the normal view, which, as I say, having looked at the presentation sampler, I find very, very interesting. We all think of harsh environments as deep hill drilling, aerospace, military, satellite type technology, and he makes a very interesting and strong case that in some situations, this is actually a harsh environment as well. So, it's going to open the eyes of the delegates to something that we think is quite benign, in some cases can also be a difficult environment for our products to cope with. So again, really interesting topics, really good graphics, and a lot of interesting material. This was, again, something that's going to be a little bit of a topic throughout the presentation. You're never going to have, or almost never going to have, a perfectly clean product. It's like the perfect solder joints. If you look hard enough, you will always find something. And these are really, really simple bullet points. And they're really key to cleanliness and reliability. Consider the end use climatic environment that you're putting this product into. It may be in a box, it may be open, it may have fans drawing air and contaminants in from the outside of the area. It may be, all sorts of potential issues. What is its cost of failure? At the end of the day, it's a very simple question. Is it worth insuring against failure? If it's a consumable product that you're going to throw away and there's not a lot of cost, maybe it's not worth investing a lot of time and a lot of money in making it safe in that environment. Maybe it's better just to throw it away and replace it. Component density, component standoff heights. These are also things when it comes to cleaning, but not only in terms of cleaning, but in removing the cleaning liquid when it's done its job. You know, the last thing you want is to put cleaning material under a low standoff component and basically have it stay there. And the key thing, and one of the themes, and I'll talk about a couple of the abstracts that talk about this later on. How clean is clean enough? You know, at the end of the day, in real live production environments, all we need is something which is clean enough. It's like we need solder joints that are strong enough. They don't have to be absolutely perfect and look beautiful. They have to be functional. And this is going to be, I'm sure, a very heavily debated topic amongst the presenters and also the audience during this event. So this is one of the things that I'm really, really looking forward to. I've picked up a little bit on a few papers that I think are good. Roth Tuttle, I've already mentioned, one of the keynotes. This talk is going to talk about failure modes associated with LEDs, operating under stress conditions, and test results that demonstrate how you can improve that long-term joint reliability with modifications to the package and also using the newer materials that are now available. So again, if anybody's working with LEDs or likely to be working with LEDs, this is golden information, no other way of describing it. As I said, I've seen the paper and I've seen the reactions in the room to when the paper was given. And yeah, it opened a lot of people's eyes. It changed a lot of people's thinking, which is absolutely that's the idea and the thrust of a keynote. So, you know, we're very pleased and very proud to have Rolf coming over to talk to us about this. And I don't like to keep repeating myself, but yeah, it is an amazing presentation. Doug Pauls, the partner of Dave Hillman at Rockwell Collins, again, really strong presentation. These guys they're pretty much involved in writing the standards. So they're the best people to talk about them, especially the new ones. And Doug is going to talk about the new protocol and talk about how we can generate evidence on contamination testers to use and control modern day assembly processes. You know, again, it goes back to my previous comments, but, you know, ionic contamination testers pretty much test the whole of the assembly. And now we're saying there's so many differences on that assembly. You know, this technology testing goes back to the days of through-hole. And in through-hole, there was a hole, there was solder on the top of it, there was flux, and pretty much that was it. There was a nice, generally apart from a couple of nasty connectors, there was pretty much an open area that was easy to clean. Surface mount came along and it got harder. Now we have bottom terminated devices with very, very small, almost minuscule standoffs. And obviously these things are potentially hotspots for contamination. So you can end up with a board with the obsolete practice of contamination of ionic testing, where the overall board tests perfectly well and it passes, but there are 2 or 3 areas on it where there's completely unacceptable ionic contamination. So again, this is going to be a really interesting and potentially contentious topic. But, you know, we have one of the best people in the world presenting it, so I'm sure he can put forward constructive arguments. Everybody knows Robert Bosch, again, one of the leading OEMs in their field, and a very interesting paper, looks at new failure mechanisms, how we can work against them, and modeling that we can do to understand the issues when These products are working at higher voltages than we would normally expect. And the presentation is looking at products that are sitting between 470 and 1,000 volts. So again, higher than is normally used in automotive, but as the technology is coming forward for electric vehicles and a whole lot of other things, this is the future. So that's it from me. I'm going to hand back to Bob, who's going to talk about a couple of the other things.
Well, thank you very much, Keith. Thank you very much for the overview of the presentation so far. So basically what I want to do is talk about a couple of presentations and also the workshops. First of all, it's probably easier for me to talk about something that I'm quite close to, as I do some work with MPL. And Martin Wickham will be giving a workshop. This is on the first day of the event, sort of 3-hour workshop dedicated to harsh environment electronics. And what this will do is look at all of the work and all of the results we've got in many different fields. So we look at protective coatings, we look at a new condensation method of testing, which I'll sort of expand on in a moment. So this is our experience over the years with lead-free technology and then transitioning into the use of higher temperature materials. And we've sort of focused over the last year or so looking at alternatives to solders with some of our collaborative projects. So all of that data and all of that information we've provided in this workshop. So I think that, as Keith said, it should be a very valuable event. I mentioned a couple of the reports which will be available to delegates. One which was an overview report we put together on materials and technology for high temperature applications, and one of the more practical things I was involved with Dr. Chris Hunt was looking at alternative techniques of soldering. Now, if you have traditionally used high temperature solders, and these are the HMP, high melting point, high lead content solders, or even tin antimony or tin silver materials, generally speaking, a lot of applications were manually soldered. So what we did is also look at automated techniques. So this is automatic hand soldering, automatic laser soldering, and also the use of selective soldering as well. So that's the sort of our overview of experience with those materials, and some of the results we got after aging again is included in one of those reports, and they're both available to any delegates that come to the conference. One of the specific areas that Martin will be covering is some work on a new test method which was developed by MPL to look at cleanliness assessment, yes, but also to look at semi-real life environments. Traditionally, we've had 95-95 testing, 95 RH, 95 relative humidity. We've also looked in the past with using different types of environment, but what the automotive industry tend to use is a specification or a test method kind of for the automotive industry, and what we look to do is improve on that. So we did some work, this is where I was involved in building these boards that you see here, which is a test board that I modified to include QFNs, quad flat, no lead packages. The reason being that these are more popularly used nowadays in automotive electronics, both 40 pin, 80 pin and 60 pin packages, which can be demanding from a process point of view, a cleanliness point of view, and also a conformal coating point of view. And this is basically the test circuit. You see I've marked out here the different locations. Location 11 and 12 is an addition to this standard IPC SIR test pattern board. But I was assisted by Doug Pauls in remodifying or changing this design to include these packages. And not only did we do the testing, but Doug Pauls also did testing on this particular product, just to get reassurance that what I was doing made sense. The new method we used for the testing, which will be covered, and talked about in the papers that Martin will be presenting in the workshop is condensation testing. And basically what we're able to now do is do condensation testing on boards, and you can see 3 of my boards in the test chamber, and we can control the amount of moisture which is condensing on a surface. So effectively, if you look at a board that we've taken out of a chamber, and this is a very basic example video clip where you can see me literally just wiping the moisture off of the surface of the board and components. What we've been able to do is condense known amounts or known volumes or known thicknesses on a surface. And this is basically by controlling the temperature in the chamber and the temperature of the subject, so to allow the material to condense onto the surface. So these are just some of the results. It gives you test chamber conditions, dew point, and a visual interpretation of the amount of condensation present on the board at these different set points. So to be able to control this gives you a more defined and more a controlled method of increasing the potential for failures. So what I'm showing you here is again just a graph which shows the relationship of temperature, both dwell and change in temperature, and the effect of condensation on the surface of the printed circuit board. And here we've got a close-up view of 0, 20 minutes, 40 minutes, 60 minutes. But by changing the temperatures of the environment this board sees, we can actually control the amount and how quickly this forms, or the moisture forms, on the surface of the printed circuit board. Now this allows us to assess conformal coating materials, base materials, track and gap widths, cleanliness. So it allows us to do a number of things when we've got a standardized test method which consistently forms a condensation on the surface of the printed circuit board. Now what I've done here is just taken some results again from some of the tests. These were boards we built in Sweden with the assistance of a number of paste manufacturers. And this is just an example of a bare board, a single coated board, where we've actually taken the board and then coated it with a conformal coating and a double coat. So this wasn't necessarily to look at the performance of the coating, it was to see what we would see when we were running through the test. And you can see here a bare board with this quite severe test. You can see a quick drop in the insulation resistance. So if you're familiar with insulation resistance measurement, we're seeing exactly the same, just interpreted or shown in a slightly different way. But you can see that a board has had a single coating of conformal coating, and then a board that's had a double coat, you can see how more protected, if you like, the surface of that printed circuit board has become. In this example, we're just moving on and just showing a paste B. Again, the emphasis here wasn't to look at the performance of the paste, it was to look at how the results would be shown on the different products or the surface conditions with different amounts of humidity. These are the actual failures on boards that were not coated, but what we certainly saw that the performance of the boards which were coated, either single coating or double dip, had no evidence of dendrite failure. Resistance would change because absorption of moisture will always occur, but we didn't actually see any dendrite failures. So it's all a matter of magnitude, what the condition was prior to and during the test. So these are all samples we see. The next present workshop that's going to be running, I think, would be extremely interesting for me personally, because I haven't been involved as much as I would have liked to have done in my early career in vibration testing. I've been involved in shock testing of product, but not vibration. And it's a very specialist field, but the idea of Alec, what he's going to try and do is demystify some of the test methods and regimes, but also look at ways in which you can predict potential failures on products. So again, it will allow you to understand more about vibration and shock testing, but also how you can apply it on your own product. And certainly the very first time I used vibration certainly showed up bad design. So if we're talking about advanced testing of NPI products prior to going into full build, doing any temperature cycling or shock and vibration is something that would show up poor design very, very quickly. I can relate to that from my experience. Now, in terms of presentations, there's a lot going on, as Keith's already mentioned, so just wanted to pick up on a couple of them. Presentation by Tony Boswell, looking at components. Now, there are a number of components which we do know we see early failures on, and this is solder joint failures. We know for a fact that within the automotive industry, a lot of companies have gone to QFN, LGA type packages, and there have been early life failures. You know, that's a fact. So solder joint failures, probably due to expansion and contraction of the package. So what he's done is looked at different techniques to overcome that. And that might be using plastic balls to actually put balls on packages. But the plastic ones are basically covered in copper, then covered in tin. So you've got a higher standoff height by adding solder to packages using either high temperature balls or collapsible balls. So again, he's looking at what they've done, how they can modify the product. Also, he'll be mentioning about some of the ways on ceramic packages. Some of you will be familiar with using copper coils or springs to give a greater standoff height but give more flexibility. Now, voids is something Keith mentioned in his presentation, and voids are always a debate. I tend to find a lot of voiding is related to the design or other aspects. A lot of customers have problems specifically with paste and profiling, but and you can do all you can do with improving your process, but at some point the paste product needs to change. You will find that certain paste products produce better void performance than others. But because you've got all those variables in between, it's just understanding what is the true cause of void. So I always say to people, find out what the root cause is first of all. Don't always blame the paste and the profile. Now, another presentation on alternative materials. I mentioned earlier that tin silver, tin antimony, HMP solders are alternatives that have been used quite widely in the industry for high temperature. But you've got to think about what high temperature is all about. In reality, if we talk about high temperature of yesterday was 150, 160, 180 degrees C operating temperature. Now what we're doing is moving on to 200 and higher operating temperatures. But if we consider, if we're still working on high temperature that we've discussed in the past a few years back, then looking at improving on the performance of those materials, because when you look at temperature cycling of some of the tin, antimony and HMP solders, the performance in terms of the joints is not necessarily as robust. It will stand up to high temperatures, but temperature cycling can be a problem. Also a presentation from Zestron, and it's interesting if you look at some of their presentations, as I have in the past. I was particularly amused, if you like, at one test method, and I actually tried it for myself, and I thought it was quite revealing, and I'll show you that in a moment's time. But Helmut is going to look at test methods and robustness of those test methods, so the actual performance of those test methods. So again, I think that might be useful, particularly if you've used standard test methods like ionic measurement for many, many years. SIR has moved on, and SIR is really the test of choice, but if you can use ion chromatography and actually being able to detect the amount of corrosive materials or the types of corrosive materials, you're in a much better place to be able to improve your process. Again, different test methods cost more than doing a relatively simple test, but again, it depends on what you're trying to find out in terms of the information. I thought that I'd create this video just to show this, and this is me just taking one of my test boards, or one of the MPL test boards, and immersing it directly into water. And what you'll see now is as we apply a voltage, you can actually see the reaction taking place that in the past would have caused dendrites and corrosions, and still does. But in this particular situation, we're actually immersing the whole board underwater and looking at the effect. And what you can actually see, obviously this one is conformally coated, and after testing, you can see the corrosion that I show in this particular photograph. The point here is that a very crude test, taking a board, if it's been conformally coated right, it will give a better level of protection, even on this rather difficult to pass test. But the company originally, when they were doing this, all they were trying to do is just look at the consistency of conformal coating, and it was quite crude but effective in actually seeing the actual results. And if you look closely, and I've taken just 4 still images here, you can see the reaction, the gassing which is taking place because the chemical reaction between the applied voltage across the gap and the distilled water, which is in this particular sample. That's top left. Top right, you can see the bubble formation, which is the gaseous reaction. And the 2 examples underneath are literally where we've got a board which had conformal coating on. It wasn't coating properly, both the surface of some of the chip components, which you see on bottom right, and certainly it wasn't protecting all the way around the QFN LGAs. Now, if we then go back to what Keith said and mentioned the reaction of conformal coating with packages. Keith talks about Dave Hillman's work on potential failure modes when you look at BGAs and you look at conformal coating. And this is not new. This is something that has been going on for quite a few years. I can remember Keith and myself working on a Dage machine, actually at a show in the US, when a customer came up to us to examine some T-SOP joints. This is thin SOP devices, and all the solder joints had failed. And what was the factor? It was a conformal coating choice that the company had made. So again, hopefully when you look at this, you'll be able to understand the different failure modes that can occur. And there is concern at the moment, and there is one technical paper out there right now about the failure modes of QFN LGA with conformal coating and the potential for issues. Now, to round up the conference, we have INEMI and SMTA. What they've done is put together an interactive forum, and the idea here is to bring a number of the presenters which are specifically involved in automotive electronics and also some users together to have a panel discussion and then break out into groups. Now, as Keith mentioned, the idea is that there will be a chairman of each of these groups, and they will specifically look at these issues. And is there potential for collaboration with companies, organizations, or suppliers? Is there an opportunity to improve or learn from others to solve problems? So the idea is that at the end of the discussion, hopefully something positive will come out that will allow groups of visitors, delegates to the conference to work together to improve. We all in the environment want to try and improve the electronics and manufacturing we build for the environment, but also for the particular applications we need for modern electronics. And that will be chaired by Grace O'Malley with an initial presentation by a gentleman from Robert Bosch. So what we tried to do, Keith and myself, and I'm going to open up Keith's mic, is give you a little bit of an overview of some of the presentations and workshops that are going to be going on at the conference. We're very excited by the range of different topics that are going to be covered at this particular event, and hopefully the practical information will be exchanged. Hopefully, Keith, can you remember that far back when we examined those T-SOP failures with conformal coating some years back?
Yeah, I can remember it, Bob, but I'm not going to tell you how many years ago.
I've still got the photographs. I actually found them the other day. That's what sort of stuck in my mind. One other interesting piece of information I thought I'd mention is 007, one of the online magazines, is also supporting the SMT Europe conference. They just joined, so it missed out on getting onto our slides, but I just thought I'd mention that. And one other thing I would sort of, I've never seen the presentation or presentations by the representative from Creed, but what I would say is that in my recent work with LED assembly, I've been very impressed with the company as a whole. They are the first company, and particularly a component supplier, who've actually given you test methods to see whether there is good compatibility between the materials you use for coating, soldering, cleaning with their devices. So they actually give you a test method to test their product out with other process assembly and materials. So I think that's quite forward thinking of them. Possibly they have had some problems in the past, but at least they've done something positive to allow engineers and designers to assess their components for compatibility, which I thought was quite an eye-opener to me.
Yeah, Cree are definitely one of the strongest in terms of technology that are out there for sure.
So Keith, over to you. Anything else you'd like to mention?
No, not at all, apart from thanking everybody for listening. Hopefully we've given you enough information and enough interesting things to come along and visit us in Amsterdam, and look forward to seeing you. Do we have any questions, Bob?
Yeah, there have been two questions from Nihal Sinadjure. I think, to be perfectly honest, best answered probably at the conference. And I apologise. There's one that I'm not aware of, but I'll pose it to you and just see. And you may be able to come back to him offline if you're aware of it. And this is a question about determining harsh environments for automotive compared with information already analysed by ITU for telecoms in harsh environments. ITU, are you aware of this organisation or institute?
No, I'm not, Bob. Sorry, but most of them I know, but this is a new one for me. But what we have seen is, a lot of the telecoms and harsh environment stuff and a lot of the automotive harsh environment results do actually overlap. But as you say, it's a conference question for the experts that are there.
Well, certainly I will take these two questions and pass them on with Nihal's email address, and hopefully they will answer the questions direct to him, or alternatively, hopefully we'll see him at the conference. So on behalf of myself, Bob Willis, I'm the technical guy doing the knobs and twiddly bits. Keith is the presenter this afternoon. I'd like to thank you all for attending. A reminder that you will receive a copy of these slides that we've presented this afternoon. And if you visit the SMT Europe website, you'll be able to pass on the link to the video recording, which will also be available prior to the show. And if you obviously visit the website, you'll be able to sign up for the conference. So on behalf of Keith. Keith?
Thank you very much, Bob, and thank you everybody for listening.
Okay, and thank you very much. Good afternoon. Good afternoon to you all.